Hey everybody, welcome back to another edition of Geometry. It's Mr. Anderson here with you. Hope you guys are doing good today. Wish I could be there with you. But anyway, we're in section 4.6 today. We're going to talk about isosceles and equilateral triangles. So let's get started. Our objectives today, first of all, we're going to use the properties of isosceles triangles. And secondly, we're going to use the properties of equilateral triangles, okay? So just remember, just kind of a brief overview here. Remember, isosceles triangles have two sides that are congruent to each other, and equilateral triangles have all three sides congruent to each other. So remember that. We talked a little bit about these before, but we'll just do a little bit more today. Okay, so we'll start with isosceles triangles, and we're going to kind of look at some terminology here. We may or may not have mentioned some of this before, but this is my isosceles triangle here, and I'm gonna label this. Okay, so I'm gonna call this A, B, C, and I'm gonna mark these two sides as being the same. Okay, so these are the sides that are the same in this isosceles triangle. So couple of things terminology-wise for you that you might want to know. All right, first of all, legs. Okay, when we're talking about an isosceles triangle, the legs are the congruent sides. So in other words, this and this, these are the two legs here. So the two legs are line segment AB and line segment AC. Okay, so the legs, when they talk about the legs of an isosceles triangle, they talk about the two congruent sides. All right, the vertex angle. All right, the vertex angle in this case is going to be angle A up here. Okay, so in other words, the vertex angle is the angle that's in between the two legs. Okay, so if this is a leg here, this is a leg, the angle that's in between those two legs is the vertex angle. So angle A in this case is the vertex angle. The base is the side that's not one of the two legs. So here's your two legs, and so the base of the isosceles triangle would be this side down here, which is side BC. And then lastly, they talk about the base angles. Well, we already said the vertex angle was this angle up here, and so the base angles will be angle B and C. Those base angles are the two angles that are touching the base. Okay, so that would be angle B and angle C. Okay, so just some terminology there for isosceles triangles. All right, feel okay with that? You good, Max? You don't know which one I'm talking about, do you? All right. Let's talk about the isosceles triangle theorem, and then, of course, the converse of the isosceles triangle theorem. All right. What this says here, if you have an isosceles triangle, the angles that are opposite of the congruent sides are also congruent. Okay, so what that means here is this. In this isosceles triangle, side AC is congruent to side BC. So when we say opposite, if you think about this side as congruent, there's two angles, angle 1 and this other angle here. Those two are touching side AC. So when we say opposite that side, it's not these two angles that are touching it, it's the other one. So in other words, we're talking about this angle over here, angle 2. So this side is congruent to this side, so the angle opposite, angle 2, is congruent to the angle opposite this side. So angle 1 and angle 2 are congruent to each other. Okay, are you following that? So here's where it says that. It says if AC is congruent to BC, then angle 2 is congruent to angle 1. Notice Those angles, what are they? They're what we just talked about as the base angles. Now, even though they're called base angles, this triangle is kind of flipped around. You know, if you think of base as being the bottom, but this triangle is kind of flipped around where it's kind of like sitting on its head. So 1 and 2 are the base angles. And so in an isosceles triangle, the angles that are opposite the sides that are congruent are the base angles. So 1 is congruent to 2. And then in the converse, it just says the exact opposite of that. If you have a triangle like this, now this isosceles triangle is kind of like tilted sideways a little bit. And so like DF here is the base. And so 1 and 2 are the base angles. And so if you go, hey, the sides that make up angle 2 is DF and EF. Okay, when we talk about the side that's opposite of angle 2, it's not either side that make up the angle, it's the opposite. So it's this side over here. And angle 1, it's not DF or DE, the side opposite of that is this side over here. So in other words, if angle 1 and angle 2 are congruent, the base angles, then FE, this side, has to be congruent to DE. So these have to be congruent then. Okay, so that's the relationship. It goes either way, but the two congruent sides make the angles opposite of that congruent, and the two angles that are congruent make the sides opposite of it congruent. Okay? All right, well, let's name a few things here. All right. Wow, I did not mean to do that. Okay, I don't know if that's crazy. And I don't even want to try to erase it, so we'll just work around it, okay? Name 2 unmarked congruent angles. Okay, so we're going to look at our triangles here. We've got a couple of triangles that make up this arrow type thing. And if you notice, here's 2 angles that are marked. This angle DCB is marked and CDB is marked. They're marked as being congruent. Okay, so it's something other than that. And so if we're going to think about the triangle situation that we just looked at. If, okay, you know what I'm going to do? This is going to be great. I don't think I've ever used this before in one of my videos, but check this out. I'm going to go to highlighter. I'm going to see, I don't know. Oh boy. Oh, there we go. Okay, so here, look at this. I'm going to highlight this triangle right here. Okay, see that triangle? Oh, sorry about that. I'm going to try to go back to my pen there. Okay, so in that triangle, look at, it's an isosceles triangle. You've got a mark here and a mark here. So what does that mean? That means that the base angles, or the angles across from those sides, are congruent. And so that means if you go across from this side, you get angle C. And what would that be congruent to? The side across from this, which goes this way, angle A. Okay, that's angle C there. And angle A, that kind of looks like I said CC and CA. All right, does that make sense? So those 2 angles are congruent because the sides opposite are congruent. Okay, let's look at another one. All right, this is the same drawing now, but we're looking for 2 unmarked congruent sides. Okay, so in the last triangle, we had the sides marked, but not the angles. And so now what we want to do is we want to find congruent sides. So I'm going to go back to my highlighter. Let's highlight this time this triangle. Okay, so now we've got that highlighted. And if you notice, the angles are congruent in this one. I mentioned that before, right? So that means the sides opposite of it, each of those angles, are congruent. So if you take this angle and you go opposite of that would be side CB. And what would that be congruent to? It would be congruent to what's opposite of C, which is side DB. Okay? You following that? Feeling okay with that? And again, if those are the base angles, since they're congruent, that means these are the sides that will be congruent to each other. And so if you notice, so CB was marked with 1 dash, which means this is also congruent. So it didn't ask us, but that would also mean this side DB is congruent to BA because that was marked with 1 mark as well. So just kind of interesting. Okay, which statement correctly names 2 congruent angles? Okay, we got a lot of stuff going on here, so we're going to have to try to figure out what we got going. And I'm not sure. I'm going to maybe do some highlighting here. And I don't know. I've never tried this before. But I am going to see if I can't. Oh, I think I can. I can highlight with different colors. Good, okay. All right, we'll start with this one. So PJM and PMJ. So PJM. So that's this angle like right here. So this angle up here, it says is congruent to PMJ. So that says like this angle. Okay, so are those congruent? Do we know for sure if they're congruent? Okay, Emma, what do you think? Okay, good. No, we don't know for sure. That's the whole thing, is we do not know for sure. Because remember, what are the sides across from it? That would be this one and this one. We don't know that they're congruent. It looks like they are, but we can't say for sure. Okay, so what else? Actually, I probably shouldn't have gone to that. I should have left it at highlighter. Let's do another color here. I'm going to go with, I don't know, like some kind of a blue thing. All right, JMK. JMK. So JMK, I'm going to kind of overlap. I don't know what this is going to look like here, but JMK is all of that angle. And JKM is that angle. Okay, what about those? What do you think? Think about this whole big triangle that these make up, that these angles are in. Look at the side across from it. Across from this one looks like has a mark. Across from this looks like it has a mark. You know what? It looks like that's probably the one. Okay, keep that in the back of your mind. Let's look at the other two just to make sure. All right, let's go to a different color here. I'm going to go to like a purple this time. So KJP. So KJP, that's this angle like right here, KJP. And then JKP, so JKP, it looks like is this angle. Again, those two look like they could be congruent, but if you look at the side across from it, they're not marked as being congruent, so we can't know for sure. And then the last one, let's go with a red. The last one then, PML. So PML would be like this here, PML. And PLK, PLK, oh, PLK would be like this. Well, those don't even look like they are, so there's no reason for that at all. So it looks like it's B, so let's see if we're correct. And yes, it is B. Okay, cool. Moving on. How about which statement correctly names 2 congruent segments? So we're going to do the same thing, but just in reverse. So let's look really quickly at the segments here, JP and PL. All right, so JP, here's JP, and PL. Okay, that just looks ridiculous. That doesn't look like they're close at all. And they're not even in the same triangle. So, no, we're going to say no on that one. All right. What's next? How about PM and PJ? Okay, so PM is this, PM, and PJ is this one. Okay, what do you think? Well, they're in a triangle. How would we know if they're the same? If their angles that are opposite are congruent, and look at the angles that are opposite. It's this angle here and that angle there. We don't know, so we can't say for sure. They look like it, but we can't say for sure. So we have to Have to let that one go. We'll say no on that one. JK is this side here, and MK is this one. Again, they look like they might be congruent, but in that big triangle, that would mean that this whole angle over here would have to equal that whole angle. And then again, it is not marked, so we can't say for sure. So hopefully this last one is going to be correct, because that's our only option left. And that's PM. So PM is this one right here, and PK. And if you notice on that one, that's in a triangle. If you look across from side PM, you have an angle that's marked as congruent. Across from that blue line there, an angle that's marked as congruent. So it is answer D. Answer D is correct. Okay, good. All right. So then a little bit about equilateral triangle. A couple of things here. First thing, a triangle is equilateral if and only it's equiangular. I believe I've mentioned this before, but let's look at it in context of what we've just been talking about with the isosceles. So remember how I said the angle across from the angle, or the sides that are congruent, the angles are congruent. So if you look at in a equilateral triangle, this side, what's the angle across from it? This angle. This side, the angle across from it is this angle, and this side across from it is this angle. So in this situation, if we follow that same logic as with the isosceles, every angle across from all of the congruent sides, they all have to be congruent. So therefore, if it's equilateral, all the sides are the same, then all the angles have to be the same. Okay, and you kind of probably already kind of knew that. And then likewise down here it says that each angle of an equilateral triangle measures 60. And so what we just talked about here is if you have an equilateral triangle, all the angles have to be equal. And if all the angles are equal, and there are 180 degrees in a triangle, then you just divide 180 divided by 3, and so you get 60 in each one of those. Okay, kind of makes sense, right? Let's look at a few examples. All right, find the measure of angle R. All right, so here's angle R right here that we're trying to find. Now, you might be able to make a guess at this because we just talked about equilateral triangles, but let's just talk about it, make sure here. So we would say this, across from these two are the same, 5 and 5. So across from this one has to be the same as across from this one. These two have to be the same, right? Okay, well, if I think of this one here, I don't know what it is, but let's say I call it X, then this one has to also be X. And so if I have two X's plus this 60, it will have to equal 180, right? Minus 60, 2x equals 120 divided by 2, and x equals 60. And so that x, both of these are x, and so that means that the measure of angle R is 60. The measure of angle R is 60. Sorry about that. Good. And you probably could have guessed that a little bit. All right, same diagram here, and we want to find PR. So all we need to know in this case is what's the length of PR. Well, you say, well, we already figured out that all of these angles are 60, right? So if they're all 60, and across from 60 is 5 centimeters, across from that 60 is 5 centimeters, so you know what has to happen? Across from this 60 has to be, what'd you say, Parker? Good. 5 centimeters. Okay? Yes, Savannah, I know you got it too. Okay. All right, next. All right, find the measure of angle T. All right, so we got some choices here. So let's look at this closely here. Remember, since 3.5 and 3.5 are congruent to each other, the angles across are supposed to be congruent. So if that across from 3.5 is 60, then across from this 3.5 has to be 60. And so that looks like that's C. And the bouncing red circle says C. Good. All right, how about this one? We want to find TS. So we want to find the length of TS. And so, of course, we already found that this was 60 degrees, right? Well, if we have 180 degrees in this triangle, what does angle R have to be? 60. And so if across from 3.5 is 60 and across from 3.5 is 60, across from this 60 would have to be 3.5. Good. All right, so that's B. Excellent. Bouncing red circle says 3.5. Whoa, okay, now it's getting more complicated. This is getting more fun now, okay? All right, so let's see what we can do to find these variables on this one. All right, so let's take a look what we got. There's a lot of numbers and variables in here, so we kind of have to work our way through this. So let's look, and so we've got two sides that are congruent, right? So let's first say, hey, that means there's got to be two angles that are congruent. So across from the 6y plus 3 is this angle E here, which is this 4x minus 8. Well, this side would have to be congruent to what? Straight across from this side, which would be this one. So those two angles have to be congruent to each other. So if these two have to be congruent and this one is 4x minus 8, this angle right here would have to be 4x minus 8. It'd have to be the same thing, wouldn't it? And if you look, you've got 4x minus 8, 4x minus 8, and here this is, 4x minus 8, okay? So they're all the same, and so we know, well, if all of the angles are the same, what kind of a triangle should this be? It's an equilateral or an equiangular triangle, and so all these angles, there's two ways, they're all the same. Sorry, I should have finished my thought there. There are two ways you could do it from here. You could do it the easy way or the hard way. Okay, the hard way is add up 4x plus 8, 4x minus 8 plus 4x minus 8 plus 4x minus 8 equals 180. And you could solve that. Or you could say, do it the easy way, which is, hey, if all these are equal, they all have to be 60, right? And so in that case, all we have to do is 4x minus 8 would equal 60. Both ways, you're going to get the same answer. But if you can kind of think through this and make just one of these equal to 60 instead of all three equal to 180, it'll be a little bit easier. So plus 8, 4x equals 68, divide by 4. And so it looks like x equals, get out my calculator, 68 divided by 4, 17. Okay, following that? All right, we still have a y in here that we have to figure out as well. Well, how could we figure that out? Okay, what do you think? Kind of think through that. Notice that the 6y plus 3 is marked as being congruent to 8y minus 5. So, if they're congruent, then 6y plus 3 needs to equal 8y minus 5. That's my equation. And then I'll solve it. So minus 6y plus 5. So you have 2y equals 8 divided by 2, and y equals 4. Good. Okay, isn't that fun? All right, I think this is the last one. All right, so find the value of each variable. Wow, that's really touchy today. Sorry about that, guys. All right, so look at our, let's start with x's. This is 3x, that's 3x. And look at, this is marked as being an equilateral triangle. So if this is equilateral, all of the angles have to equal as well. So that means this also has to be 3x. And if that's 3x and 3x and 3x, how many degrees do each one of those angles have to equal? They have to equal 60. So we'd say, 3x has to equal 60. Divide by 3. X equals 20. So we know we can cross out either D or C. We know it's got to be A or B. So now let's figure out y. And if you look at y, you go, okay, what could I do there? What do you think? Hey, I've got some sides that are congruent to each other. So 2y minus 6 could equal 8. And then we just do plus 6, 2y equals 14, and divide by 2, and so we have y equals 7. And so that would be B. Magic red bouncing circle, please show us the way, and it is B. Good. Okay. Well, that's it for this section, I think. There we go. Just wanted to make sure. I forgot one time. Appreciate you being here. Thanks for watching. I hope you learned a few things, and we'll see you next time in geometry. This is Mr. Anderson. See you soon. Bye.